Hey guys, I wanted to record this because I'm going to be gone tomorrow, but I really don't want us to get behind another day on notes. And so I'm just going to talk through some of the slides and things, and then you're welcome to pause this or go ahead or back as needed to fill in the different parts of your fill in the blank notes. And I know most groups had already talked about this, but just as a reminder about the cartilage, we talked kind of about the hyoid bone up in here and how as the cartilage underneath that provides that protection and support, the shape really almost forms like this nice ring around your throat, which is kind of a neat deal. The other cartilage, we had the arytenoid cartilage, the cuneiform cartilage, and the corniculate cartilages, each kind of forming that lateral and posterior wall of the larynx, which remember is so important because that's where your vocal cords are. And so we need this place to be really stable and really protected. There's some diagrams of this cartilage in the different areas. You can see here kind of a side view where we can see that vocal cords folding, and then we can see a front view here with all the different cartilages shown. So make sure you're familiar with these diagrams, study them up. You never know what you might see on a test. As far as the epiglottis, I'm going to move myself down here on this line. You can see here that the epiglottis, which we found in our minks, most of us, is this nice little piece of cartilage flap that attaches and covers over the throat whenever you're breathing or swallowing. And so this is the thing that's going to divide the esophagus and the trachea. It is attached at the base to the rim of the thyroid cartilage, and then it projects upwards to the base of the tongue. And so that's what's going to allow, again, things to either go down the correct pipe if you're breathing or down the esophagus if you're swallowing liquid or food. And one of the groups actually asked, I think it was 8th period, about how this works and how it can actually know whether it's liquid or food. And so I wanted to show, I had a quick little aside here. This was the same question that an 8-year-old girl named Molly Tornis asked to a leading scientist, and this other lady, whose name happens to also be Molly, said that basically the epiglottis knows what's coming because of nerve endings, and there's these tiny little nerve endings that pick up on what's coming towards it, sends a message to the brain, and then the brain decides, oh, water, oh, air, and it happens instantaneously, which is really kind of a neat thing that our body can do. You can see here the shape of a shoehorn for those who are not familiar with being 100 years old and using those to put our shoes on every morning. But whenever something does go down into the trachea, as we've talked about, it's obviously going to trigger a very violent coughing reflex. Next, I'm going to move myself off screen here. We can see the vocal ligaments, which we've talked about before, just being the vocal cords, which are not really cords, they're more of a fold, as you can see here. And they're very elastic. And so as air passes through these, they're able to move and vibrate hundreds of times every second, and they can make different sounds. Those white mucosal folds you can see here are the things that we would call the true vocal cords. There's also false vocal cords that can be moved in order to create different sounds. And if you've ever looked up any kind of videos of vocal cords flexing, especially looking up like any screamo music or heavy metal, you can see some really weird stuff where people's throats move in dramatic ways and it makes really freaky sounds. For the most part, what we need to know is that there's two sounds primarily, the upper pairs, which is the combination of the ventricular folds and the false vocal cords. Those don't actually make true sound production. Those just aid in the production of sound. Whereas the lower pairs, those true vocal cords, actually vibrate when the air moves, and they produce sound as things are coming up from the lungs. Here you can see a GIF of that vocal cords opening and closing. It looks a little freaky, I know, but this is down in your throat. And most of these videos are gathered because they'll put myself back up here, and they'll poke down and watch as people are speaking or singing or doing all kinds of different things. So as far as voice production is concerned, this speech, or what we'll term as vocalization, is just opening the mouth, obviously expiring air, and then opening and closing those true vocal cords. Now, depending on the force with which that air comes out, you can either make a really strong vibration, which obviously would be a louder sound, or if you're really, really quiet, that would be not very much air coming out. So sorry if that destroyed your earphones or earbuds. But the quality of sound is more dependent on the action and activity of the pharynx and the oral, nasal, and sinus cavities. And so this gets into like your ideas of voice training and learning how to produce these different sounds. You can amplify different sounds. Obviously, the musculature of your face comes into play. The shape of your mouth. Those of you who are in choir are very familiar with all these things. In order to go from things like normal speech and normal enunciation to doing just generally some weird things with your voice, which is possible. There's a video clip here on the larynx, and I encourage you to take a minute and watch that. I'm not going to show it here because it'd be a bit weird to have a video on a video on a video. So we'll skip that. And then we'll talk a few more slides, and then I'll let you color and work on some other things. So as far as the trachea and windpipe, as we continue our way down, the trachea is that tubular structure that extends down from the larynx, so remember our upper larynx, down through the neck, anterior to the esophagus. And so the esophagus goes down behind it. So this is why sometimes when you swallow something really big, it kind of pushes on your trachea and you feel like you're choking, because they're right up next to each other. Down into the mediastinum, which is where it terminates by going into our, as we know, left and right bronchi. And so if we were to remove our heart, we would be able to observe that really easily like you could in your mink. Structure-wise, it's mostly smooth muscle, so it's going to automatically push that food. Pardon me. Big yawn there. It's going to push that food down into the throat as you're swallowing, which is nice. And for the most part, it has 16 to 20 C-shaped rings of that hyaline protective cartilage all the way down it. This was those white rings you were seeing on your mink as you looked at its trachea. And it also has the PCCE, which hopefully you remember is pseudostratified columnar ciliated epithelial. That was the one that had all the little fingers on it that sweeps the mucus down the throat and also helps get rid of any kind of debris or dust that you might swallow, which is happening all the time because you're always breathing in dust and nastiness. Okay, and yep, we have a diagram here. So you can see the diagram of the trachea. This is a cross section showing the different types of cells, and you can see that those mucus glands that are all throughout that are going to produce mucus, which helps keep this nice and moist, nice and coated, so that things can slide down it easily. In this diagram, you can see another view. This is actually further down into the bronchi, so you can see the mucus coating is a little thicker here because we're getting ready to do some gas exchange as we move into the secondary bronchi and the alveoli. And then in this one, this might look familiar. You should see your friend here, the pseudostratified columnar ciliated epithelial. And you can see the cilia here, those little fingers. And we sketched this in the tissue lab, so hopefully that looks familiar to you. All right, and then the last thing I want to talk to you about today is disorders. So looking at the disorders of the lung, there are several, and we'll spend more time talking about this in person so that I can really hammer it home that you shouldn't smoke. But smoking is one of the worst things you can do to your lung because it actually slows down the ciliation that allows the mucus to move through your respiratory tract. So let me move myself over here. So by destroying those ciliated cells, it makes it really difficult for things to go through your system, which is going to leave the cough reflex as your only way to clear all those secretions. This is why people who smoke a lot have a really generally nasty cough, that deep smoker's cough. It's like, oh, and it's really nasty. And part of why it's nasty is because look at their lungs. Goodness, really destructive. And then you can see the creepy lady on the lady here, showing the old age and the wrinkles and all the other things that are associated with smoking, which is just a terrible thing. Most of this is based on smoking of cigarettes and cigars, but we'll talk even more about vaping and how it's even worse than all of these things later. We'll watch this video when we're together, and that is a good place to stop. If you want to work further in the notes, you're welcome to do so, but I didn't want to go too far and leave you just based on this video. So hopefully this was helpful, and we will continue these next time.